Hey, what's going on, guys? Welcome back to my channel. In today's video, we will be reviewing what additive, semi-additive, and non-additive facts are. Why is it really important to know about them? How useful they are, and why should you know about them? Okay. So first, I would like to do a briefly explanation of what is a fact. And a fact is actually a quantitative measure that represents a business event. Okay, just like that. It helps you with answering the following questions like how much or how many. So, for instance, if you have a purchase amount data set, you can actually answer, hey, how much money we are making this month, or how much money we made the last month. Okay, how much money we will be making the next month. Okay. And the other one is the click count in the web page. With this, we can actually answer, hey, how many people have visited and click this specific button, okay? And so on. You can add other examples, but this is just really straightforward. It's a quantitative measure that represents a business event, and that helps you to understand how much and how many in a contextual of well, it can be a lot of things, right? Like purchasing, like weather, like a lot of things, right? um, what is important for you to know about these additive, semi, and not additive effects? Well, this is pretty straightforward because sometimes as data professional we don't stop to think what kind of data we're dealing with, even when this is obvious. And I've seen it several times with a lot of analysts that they work like robots, but they don't stop to think what kind of data they're dealing with. And this is really important because in data analysis and data engineering, there is a concept called data modeling, and knowing these concepts would actually help you to understand what data modeling who will help you to how can you actually leverage the most of the data modeling concepts, like denormalization or normalization, by knowing these specific concepts. Okay, so just as I said, this is well, this is an advice uh, for you, because knowing these concepts, as I said before, will help you create better data models. Okay, so for instance, let's say that you want to merge two tables into a single one table to reduce complexity. Knowing these concepts will help you to ask yourself, are these tables equivalent, or even is it logical to merge them? Well, that's what knowing. That's why knowing these concepts will help you with achieving this specific task. Okay, and I brought you some examples of this, and I want you to consider two data sets. Right, one contains the total balance of a loan, and the second is a detail of the payment amount for that specific loan. Okay, so you have two tables, as you can see. One is a snapshot of the balance amount. This is the balance table, and the second one is the record catching of the is most known as transaction table. So in the first table, as you can see, you have a loan ID, you have a balance, and you have a date. Okay, so let's say that you want to merge these two tables. Well, it will be better for you to, if I explain this to you. Well, the first table represents a record, is actually a snapshot, as I said, of the balance of a specific loan ID. Okay, so for instance, this loan ID have a balance of $200 for the date of 30 January 2025. But as you can see, the date right after, it decreases until $185, the 31 January 2025. Okay, and yeah, this may sound really straightforward, we can say that this loan ID decreases its debt by $15, right? So if we look at the record caption of the transaction table, we can see that this specific loan ID, the client actually paid $15 if you sum up these two records here in the same day. Okay, that is the key part of this. The client actually made these payments the same day. Okay, and the third one wasn't a pay. There was no pay, so you won't see this row, or will be displayed as 0. Okay. So what we can infer here is that yeah, the balance is actually correct. The client made two payments of $105 each. I mean $10 and $5 each. Okay, so making $15. So the challenge here is we want to reduce the complexity of our queries. Okay, so well, to solve this, there's a lot of ways. I will tell you 3 ways you can solve this by actually using these concepts of above. So the first way is a single table, which is called one big table, right? Is becoming more and more popular between the cloud analysts, because it's more it breaks the complexity into columns, as you can see here, right? And what I just did is that I joined these two tables, right? I brought the loan ID, the balance, and the date of the first table, right? And then I added the payment amount of the second table. Okay, so as you can see, what I actually did is to sum up these two records here, as they were actually made the same day, the 30 January 2025, and I added a kind of a flag. Well, it's not a flag, it's actually a date. The date of the last payment that shows that this paid was actually made the 30 January 2025. And you can keep actually this same record, right? The next day, the 31 January 2025. So as you can see, I reduce this complexity into a single table by using the one big table approach. Okay, so if you don't understand this at first, I will really encourage you to search for more complex less complex examples of this. But it's just really straightforward. You just mix these two tables into a single one, trying to make this a more friendly way, make it looking for a more friendly way to analyze these two tables. Okay, so the second way is nested fields. Okay, so this is more advanced method. Also, it's really popular between the cloud analysts, because you can see this in AWS or GCP and other platforms. And the clue here is that you don't actually separate the complexity into columns, but you nested them into a single column. Okay, so for example, just as above, I have the loan ID and the balance. Okay, but as you can see, well, this is not the row date, this is the date. Okay, just to keep it simple, more easy to understand, we keep the date. And what we do with the transaction table is that you add this into a single column, right, called payments column, and you nested all that fields from the record table within a column in a key pair value. okay? I mean, key value per, okay? And with this, you can actually do some queries, find how many payments this customer did in a specific date without having to break this into multiple columns, okay? Once again, this is a more complex, more advanced method, and if you want to learn more about this, I really encourage you to search for it. Just nested fields in AWS or nested fields in GCP. The Google resources are really straightforward and really friendly, so you have a better understanding of what I'm meaning with these nested fields, okay? So the third way and the last way to approach this problem, this challenge, is to actually create a star schema with the kimball approach, okay? What Kimball proposed, which has been actually used by many industries across the world, is that you can have one or multiple fact tables, right? Remembering that the fact table is this, just the transaction table, and another fact table is this one, the balance table. Okay. So you can have multiple tables in the same model, right? Just like this. And what is really interesting here is to know that you can have two or more multiple tables, fact tables. And what's really interesting is that you can add some dimension tables that give context to these fact tables, okay? So instead of having, I don't have any column that can show you a more clear example, but let's just say that you want to analyze how much that you want to get the currently balance and the total payments and a specific client has done in the last month, okay? So for this, you will have to actually query the two tables, but adding the dimension tables that actually have the name, the address, the area, the city of this client, right? And ranking them to see which client made the most payments to its loan, and so on, right? But this is a different approach from the ones that I was explaining to you, because this is, I don't know if this is even more complex or easier to you, but what I can tell you is that it's used across all different industries, right? But it's actually the most known approach for this kind of challenges, as these keep the complex a little bit easier for analysts to really understand, okay? Because they know what specific tables and columns they have to retrieve from the databases, okay? So these are the three methods that that you may be facing in your career as a data professional, but these are all or could not have been done without knowing the really basics of additive, semi-additive, and additive facts, okay? So now let's talk about the main concepts of these facts, okay? So what are the additive facts? These are facts that can be summed across all dimensions, okay? So one example of this is the record table, okay? Because in the record table, as you can see here, you can sum up payment amounts, and you can sum up the payment amount column, and given that there is no repetitive payments, right, you can say that if you sum up this column for the month of January 2025, the total sum will actually be correct, because you have this you're confident that this data will not be repeated. Okay, there's no duplicated records, and one transaction is each of these transactions are true. Okay, so you know that if you sum up this, once again, this payment amount in this given month, and actually if you want, you can add the customer name, or the customer I don't know, personal ID, etc. You will actually be given the correct sum. Okay, and the second one is the semi-additive facts. So these are facts that can be summed across some dimensions but cannot be logically summed across other dimensions, most notably time. Okay, so consider this example, the balance table. Okay, as an example of this. Okay, so the balance table actually is a snapshot of this same loan ID across different dates. In this case, partitions by day. Okay, so if you sum up the balance column, you will actually get the incorrect sum, because it is not logical to sum up a balance column, because it is a snapshot of the same day. It is a snapshot of that loan balance, right? Over several days, okay, in the same month. So if you sum up this, you will get an incorrect sum, and that for any business will be leading to a lot of misleadings and errors that can cost it can cost so much money for them. Okay, and the last one is not additive facts. So these are facts that cannot be summed across any dimension. Okay, because summing them between records or fact rows produces a completely meaningless or mathematically incorrect number. So consider, as an example of these, percentages calculations that, if sum up, does not give any value to the business. Okay, so with this, I think we are done with this explanation, and I hope you learned something today.